Given two numbers, a and b, incommensurable in square, whose sum of squares is medial, and whose product is medial and incommensurable with the sum of squares, we'll show their sum a plus b is irrational. Let d be rational and let df equal a squared plus b squared, and dh equal 2ab so that d times h plus f is equal to a squared plus 2ab plus b squared, equaling a plus b squared. Now df is medial, and d is rational, so by proposition 1022, f is also rational but incommensurable with d. Similarly, h is rational but incommensurable with d. By assumption, ab and a squared plus b squared are incommensurable, so 2ab and a squared plus b squared are incommensurable. So df and dh are incommensurable, so that f and h are incommensurable. But f and h are rational, so f and h are commensurable in square only. Thus f and h are rational numbers commensurable in square only. So f plus h is irrational and is called binomial, which was defined in proposition 10.36. So d is rational, so d times f plus h is irrational, and d times f plus h equaling a plus b squared. So a plus b squared is irrational, so a plus b is irrational. This is called side of the sum of two medial areas. Therefore, a side of the sum of two medial areas is the sum of two numbers incommensurable in square, whose sum of squares is medial, and whose product is medial, but incommensurable with the sum of squares. An example of such a number is the square root of root 10 plus root 8, plus the square root of root 10 minus root 8. To show this, let a equal the square root of root 10 plus 8, and b equal the square root of root 10 minus root 8. A squared equals root 10 plus root 8, b squared equals root 10 minus root 8, and a squared over b squared is equal to root 10 plus root 8 over root 10 minus root 8, which is equal to root 10 plus root 8 squared over root 10 minus root 8 times root 10 plus root 8, which is equal to root 10 plus root 8 squared over 2, which is equal to 18 plus 2 root 80 over 2, which is irrational, so a squared and b squared are incommensurable. A squared plus b squared is equal to root 10 plus root 8 plus root 10 minus root 8, which is equal to 2 root 10, which is medial, because its square root is the square root of 2 root 10, which is the geometric mean of their numbers, 2 and root 10, which are rational by Euclid's definition and commensurable in square only. ab is equal to the square root of root 10 plus root 8 times the square root of root 10 minus root 8, which is equal to the square root of root 10 plus root 8 times the square root of 10 minus root 8, which is equal to the square root of 2, which is medial, because its square root is the square root of 1 times the square root of 2, the geometric mean of two numbers, 1 and root 2, both rational by Euclid's definition and commensurable in square only. The square root of 2 is not commensurable with 2 root 10, so a squared plus b squared is incommensurable with ab. Thus, overall, the square root of root 10 plus root 8 and the square root of root 10 minus root 8 are incommensurable in square, whose sum of squares and product are both medial but incommensurable. So, the square root of root 10 plus root 8 plus the square root of root 10 minus root 8 is a side of the sum of two medial areas. When looking for such a number, the form the square root of root a plus root b plus the square root of a minus root b may be helpful, but be sure to check all the conditions.